Hi everyone, it's Math with AUB. For the preparation of especially IBA direct test, I have chosen the topic function. With function related, there are functions. What do you mean inverse function? What do you mean domain function? Domain of the function, range of the function, composition of the function, where function is defined or not defined, or what do you mean by vertical test to check whether the given graph is function or not. Let's see and find out all these things in a single frame and in a simple manner. Don't you worry, there is no space, little space to write. I can manage the space. I can open up each and everything. Our topic is functions, domain range, and more. Here, some relations are given. Some relations are given. Some relations are given. We are asked to find which one is function or not. Which one is function or not. I am checking all these for you. Whether it is function or not, first one is known as domain. The second element is known as range. It's our domain, it's our range. Domain and range, domain and range, domain and range. So, domain and range is the concept that is related with the relations as well as functions. Domain, taking the first element, writing the first elements 2, 4, 5, 6, 7 without repetition. That is our domain. What about range? Our range is simply 1, 3 and 0. Not repeat. Repetition is not allowed. That is our domain, that's our range. That is the side concept. Where we have to correct whether it is function or not. Whether it is function or not. Look at this. For each input, we have a unique output. Unique output. 2 is related with 1, it's okay. 4 is related with 1, it's okay. 5 is related, it's all are okay. All are okay. Yes, number 4 is a function. To each input, to each input, there must be a unique output. There must be a unique output. Unique output. Unique output means just you have to take care a single input cannot give us more than one value. Single input, there must be single output, no double output. If that is the case, then it is not a function. A single input gives two different values. If single input gives two different values, then it is not a function. Otherwise, it is function. So 4 is our function. It's our function. What about this? Look at this: 0 to 1, 2 to 1, 3 to 2, 4 to 5, 3 to 1. It's also a function. It's also a function. Unique input gives us unique output. There is no concept that a single input gives double output. That is not the case in that case. Look at this. While it is not a function because 2 gives rise to 1 as well as 2 to 2, 2 to 3, 2 to 4. No, it's not a function. It's not a function. It's not a function. Why? Because single input 2 is related with 1 as well as to 2 as well as to 3 as well as to 4 as well as to 5. It's not a function. It's not a function. It's not a function. It's not a, because single input result in single output. Single input, single output. More than one output of the same element, more than double one output, more than one output of a single element, that violates the definition of function. That violates the definition of function. So it is not a function. It is not a function. What about this? 1 to 1, it's unique. 2 to 1, 3 to 1, 4 to 1, 5 to 1. Yes, it is a function. Look at this. Let me make some space to give you a good idea. Such type of function is known as constant function because domain consisting of single element 1 results in 1 as well as 2 also goes to 1, 3 also goes to 1, same one, as well as 4 goes to 1 as well as 5 goes to 1. Such type, it is also a function because unique input results in unique output. However, two inputs have same output. It is possible. Single input, more than one inputs have same output. It is possible. It is possible. It is possible. It is also a function. Such type of function is known as constant function. Constant function where a range consisting of single element. Range consisting of Single element, range consisting of single element, it's a function. It's a function, but it's a constant function. It's a constant because its range consisting of singleton element. Look at this. Range comprises only one. Range comprises only one. It's a function. It's a function. If single input has more than double output, single input gives more than one output, it's not a function. It's not a function. Okay. I am selecting this question for you in order to clarify the situation function. What about this as well? And then we can proceed to other question. First, clarify the situation whether it is function or not. Just check. Now, in that question, we are asked 3 2 4 2 3 1 7 1 2 3 is said to be a function. Then which one must be removed? Which one must be removed? Look at this: 3 to 2, 4 to 2, 3 to 1, 7 to 1, 2 to 3. Look at this. Where lies the violation? There lies the violation, because 3 is related with 2 as well as 3 is related with 1. For single input 3, there are two outputs, two different outputs. Either to eliminate this in order to make this function, or to eliminate 3 1. Either I eliminate 3 2 or 3 1, then it's going to be a function. If I eliminate this one, then I have 4 2, 3 1 and 7 1. It's a function. It's a function. It's a function. However, if we remove this one, 3 1, it's also a function. 3 2, 4 2, 7 1. It's also a function. It's also a function. Sometimes it is given to us. It is if it is not a function, what should be removed to make this function? What should be removed to make this function? Where lies the violation? 3 has double output. 3 has double output. 3 has image 2 as well as 3 has image 1. It's a violation. Either to delete this, it will give us a function. It's a function. It is also a function. It is also a function. I hope you have a good idea about this. You have a grasp whether to check whether it is a function or not. If such type of to circles and interrelated questions images are drawn, it is really very easy to check whether it is function or not. Look at this. First we have 2 5 8. 2 is related to 1, 5 with 2, 8 with 9. We are okay. It's a function. It's a function because suppose there is f single input results in 2 to 1. 2 has image 1, 5 has image 2, 8 has image 9. It's cool. It's function. What about this? F of 8, it's also 9. It's a function. It's a function. It is 1 1 as well. 1 1 as well, because single input has unique output and it doesn't repeat. F of 2 has single different image. F of 5 has different image, and F of 8 has different image. Nothing is overlapping in range as well. It's 1 1 function. 1 1 function means 1 1 function means look, in case of function, it is also possible 5 goes to only 1. 5 also goes to 1. It is also possible. It is also possible. In that case, 2 and 5 have same image. In that case, 2 and 5 have same image. It is function but not 1. It is function but not 1. Look at this. Different elements have different images. Different elements have different images. Different elements have different images. It is definition of 1 1. 1 1 is also called injective. 1 1 is also called injective. Look at this. Range is completely involved in the domain. Range is completely involved in the domain. It is known as onto function. Onto function. If range is completely involved in domain, if range is completely involved in domain, or simply no element of range is missing, no element of range is missing, it is known as onto. Onto is also called surjective. Also, onto is also called surjective. If a function that is 1 1 and onto, that is 1 1 and onto, it is known as bijective function. Bijective function. Bijective function. Some people call it bijection. Some people call it bijection. It's okay. It's a bijective function. It's a bijective function. It's a bijective function. Bijective function. Okay, cool. Moving towards second option. To check whether or not it is function or not. Let me. Second seems to me. Let me draw this. 3 has double image. 3 goes to 6 as well as 3 goes to 10, while 5 also goes to 10 and 7 goes to 14. Look, there lies the violation. 5 is related with 6. 3 has double image. 3 has double image. 3 leads to 6 as well as to 10. And f of 3 also 10. This is violation. This is violation. Single input results in single output. There is a double output. 3 has double image. 3 has double image. 6 as well as 2. 3 has double image. 6 as well as 10. So it is not a function. 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 It's not a function. What about cool? Let me check question number, option number 3. It's a good one. To me, it's a good one. 7 related with 10. 14 is related to nothing. 21 is related to 16. Look, 14 has no image. 14 is no image. It is violation of definition of function. Each element of the domain has unique image in Y. Each element of domain has unique image in range. Each element of domain, each 14 has no image. 14 has no image, so it is not a function. 14 is not related with anyone. 14 is not related with anyone. It's not a function. 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 Okay, I have given you a good idea about this one. It is also a function. Simply one can check its function. So I have given you the idea what do you mean of function, what do you mean by injective function, one-to-one, what do you mean by onto function or surjective, or what do you mean by bijection. Moving towards first question, compute the range of these values. We have given function f of x, that is 3x plus 1 over 2, and we have given domain 1, 5 and 11. These are the values of x. Domain means values of x. Input, put values of x to get range, range means values of f of x. Put f of 1 instead of x, plug in 1, 3 times 1 plus 1 over 2, f of 1, it will become 4 over 2, 2. So image of 1 is 2, that's our range. What about 5? Plug in 5, f of 5 means instead of x insert 5, 3 times 5 plus 1 over 2, 3 5 the 15, 15 plus 1, 16, 16 over 2 means f of 5 is 8, f of 5 is 8. Finally, plug in f is equal to 11, instead of x put x equal to 11, 3 times 11 plus 1 over 2, 33, 33 plus 1, 34, 34 divided by 2, 17, 34 divided by 2, 17. Pass me the marker. It's not writing doc. Yes. So the range is 2, 8 as well as 17. So the range is 2, 8 and 17. So the range is 2, 8 and 17. 2, 8 and 17. Where is the marker? Here I have. That is really nice. Yes. So this is our range 2, 8 and 17. I have given the domain. Domain means values of x. Domain means values of x. Domain means values of x. Instead of x, insert all this. First I insert 1, 3, 1, 3, 3 plus 1, 4, 4 divided by 2, 2. So f of 1 is equal to 2. F of 1 is equal to. Then plug in f is equal to 5. 3, 5 the 15 plus 1 divided by 2. 15 plus 1, 16, 16 divided by 2, 8, 8. And finally 11. 3, 11 the 33 plus 1 divided by 2, that's 17. So our range is 17. So how to write this? In function language, look at this domain, and here its range related with f of x. Here lies the domain. 1, image of 1 is 2, image of 5 is 8, and image of 11 is 11 of image of 11 is 17. So these are the values of x domain 1, 5, 11. On insertion of 1, the result is 2. I have written, means f of 1 is equal to 2. F of 1 is equal to, image of 1 is 2, image of 5 is 8, and image of 11 is 17. That is the way to write in boxes. At your level, that is tiny concept to check. Otherwise, functions are some tremendous discipline in mathematics, a hard nut to crack. Okay, moving towards next question. We have done 1, 2 as well as this one. Now moving towards question number 3. F of x is given, it's some sort of quadratic function. F of x is given by 3 times x square negative 2 times x plus 4. And then for which value of x? F of x is equal to 20. We have a guy f of x having value 20. Right, instead of f of x 20, then solve for x. Or from function point of view, we have given a range. We have given a range of 20. We have to find its corresponding domain. Or simply the guy sitting here f of x, its value is 20. Put 20 and solve for x. Here lies 20. We have 3x square minus 2x plus 4. Shift 20 on the right hand side. It will become 3x square minus 2x plus 4 minus 20. Look at this. Positive 4, negative 20. It results in negative 16. 3x square minus 2x minus 16 is equal to 0. Either to apply quadratic or midterm breakup. There is 3. There is 16. 16 means 2 into 2, 4 times. we have to make just 2. 2 to the 4, 4 to the 8, and there lies the 3, 6. If I write minus 8 plus 6, I will get minus 2. I have 3 coefficient of the x square term as well as the coefficient as well as the constant term. Coefficient of x square term as well as the constant. They result in the factorization 3 times 2 times 2 to 4 times. So I have taken 2 to the 4, 4 to the 8 and 6. Minus 8 plus 6 gives me minus 6. Minus 8 plus 6 gives me minus 6. So middle term breakup, or you can switch over to quadratic. 3x square negative 8x plus 6 minus 12. This type is known as middle term breakup. I have taken 3, the coefficient of x square as well as 16. I have taken 3 as well as the coefficient of 16. 3 16 the 48 and 8 6 the 48. 8 6 the 48. I need negative 2. I have taken negative 8x plus 6x. I would have, if there is positive signs, I would have written plus 8x minus 6x. Taking common, x common, we have 3x minus 8 plus 2 common, we have 3x minus 8 is equal to 0. Either or. So this complete bracket is identical. It's good to go. That is the validity. Our middle term breakup is perfect. 3x minus 8 is one bracket. Other bracket is x plus 2 is equal to 0. Solving for x, 3x minus 8 is equal to 0. 3x is equal to 8, or x is equal to 8 over 3. X plus 2 is equal to 0, and x results into when function f of x is 20, function f of x is equal to 20, this range is connected with two elements of x, that is 8 over 3, that's minus 2, or one can write in function notation, means f of negative 2 is 20 as well as f of 8 over 3. 8 over 3 is also equal to 20. One can put the values, plug in the values of x to verify this one. Let me read the question again for you. If f of x is equal to 3x square minus 2x plus 4, find the value of x for which f of x is equal to. Here the guy f of x having value 20, just plug in the value of f of x 20, then solve for x. Or more mathematically, range is given. When the function having range 20, we are asked to find its domain. That's domain results in negative 2 and 8 over 3. Cool. Here it is known as composition of function. Next question is based on, we have given an exponential function linear function 4x minus 5 and an exponential function 3 to the power x. Then we are asked to find f of g of 2. How to calculate, how to negotiate this term? Let's see and find out. Making life simple, remain simple, and work straightforward. F of x is, it's a linear function. F of x is 4x minus 5, and furthermore g of x is 3 raised to x, 3 to the power x. We are asked to find f of g of 2. first solve this one, g of 2. G of 2. We have to solve first g of 2, then towards f. From inside out. From inside out. First we have to solve g of 2, then it's f. It's known as composition of function. G of 2. Instead of x, put 3. G of 2. It is 3 raised x. X means 2. So g of 2, 3 square means 3 into 3. It results in 9. So value of g of 2 is 9. G of 2 is 9. Function value of g of x at x is equal to is 9. So instead of g of 2, now write 9. So I have f of g of 2. G of 2 means 9. G of 2 means 9. F of 9. F of 9. Again, it means in function f of x, insert instead of x 9 or put x is equal to 9. Put x is equal to 9 in f of x. That is our f of x. It's equal to 4 times x minus 5. Instead of x, we have to insert 9. 4 9 the 36 minus 5. 31 is the answer. 31 is the answer. Composition of f of g of 2 is equal to 31. Is equal to, that is the way to calculate composition of inside out. First calculate g of 2. G of 2. G of x is given to us. G of 2 means instead of x put 2. So our value of x is equal to g of 2 means 3 square. 3 square means 9. G of 2 results in 9. So instead of g of 2, I have plugged in 9, 9, 9. F of 9. F of 9 means function value of f of x at x is equal to 9. So instead of x, write 9. 4 times 9, 36. 36 minus 5. That's our 31. 31 is our answer in that case. Here we are asked to find the domain of the following functions. Domain of the following functions. In case of domain, we have to take care of two things. If log is not present, two things. A radical never results in negative. Radical never results in negative because these are real valued functions. Real valued function, if negative sign is present in the root, square root, under root, it means it's a complex number. It's a complex entity. It's not a real number. So we have to eliminate this one. And second, denominator doesn't vanish. Denominator doesn't vanish. Let's sort out one by one. F of x is root x minus 2. X minus, these are real valued functions. Otherwise stated they are real valued. R2 are real valued function. Square root can never be negative. Square root can never be negative. If there lies the minus sign in the root, then it's equal to iota. Iota means complex number. We are dealing with the real number. It means we need x minus 2 greater than or equal to 0. X minus 2 greater than or equal to 0, or x is greater than or equal to 2. X is greater than or equal to 2 is our domain. Means if I draw domain O 1, 2, minus 1, minus 2, greater than 2, 2 greater than or equal to 2 is inclusive. 2 is inclusive. Greater than means toward the right hand side, toward the right hand side, toward the right hand side. Either to draw a picture like this, 2 is included on the right hand side, or one can write in that fashion, 2 towards positive infinity. That's our domain. Either write this, might be this, whatever the option is present, just take all these three are correct. Positive 2 to infinity. Positive 2, if I put 2 here, 2 minus 2, 0, 0, square root of 0 is 0, it's good. If we put any quantity less than 2, if I plug in 1 here, 1 minus 2 results in minus 1. Minus 1 means iota. It is not a real quantity. That's why 1 is not allowed. That's our domain starting from 2, inclusive 2, and moving towards right hand side. Moving towards right hand side. That's our domain in that case. The second question is based on having denominator f of x is equal to 1 over x minus 2. In case of denominator, in case of rational functions, such type of function, if variable is present in the denominator, it never results in 0. It never results in 0. Just simply calculate denominator is equal to 0. X minus 2 is equal to 0. Gives us x is equal to 2. So we can never put x is equal to. If I put x is equal to 2 minus 2, 0, and division with 0 is not allowed. Division with 0 is not allowed. Then we can write our domain is all real numbers. Our domain is all real numbers excluding 2. Excluding 2. We cannot insert x is equal to in that function. That is exception. That is exception. We cannot take x is equal to. What is domain? We can plug in all real values, whatever you want. except x is equal to. If we put x is equal to, then the denominator ceases to exist, it is 0. Deviate with 0 is not allowed in mathematics. In case of root, we cannot afford any negative quantity in root. Negative quantity cannot be affordable in root. And in case of denominator, we cannot afford denominator is equal to 0. Let's see another question 3. That's also having denominator. F of x is equal to 1 over x minus 4. Here we have f of x is 1 over x square minus 4, a rational type function. Denominator never be 0. How to get rid of this? Just solve denominator equal to 0. X square is equal to 4, or taking square root, having plus minus sign, x is equal to plus minus 2. That's the exception. We cannot take, if I put 2 here, 2 square 4, 4 minus 4, 0, denominator 0, never be required. If I put minus 2 here, minus 2 square also positive 4, 4 minus 4, 0. So our domain is all real numbers excluding plus minus, excluding plus minus, or more mathematically one can write negative infinity to negative 2 union negative 2 to positive 2 union positive 2 to infinity, positive infinity. That is the way, a mathematical way to write. Otherwise it is suitable. It's simple one, everybody can afford it, everybody can understand it. Keeping the life simple, that's the option. If they have written some type of mathematical, then just we have vanished plus 2 and minus. Look at it, minus infinity to minus 2. Minus 2 has been excluded, it's open interval. Minus 2 to positive 2, negative 2 is excluded, as well as 2 is excluded. From this 2 to positive infinity, 2 has been also excluded. If I draw a line, then here 0, 1, 2, minus 1, minus 2. Look at this, it is open. Open means minus 2 is excluded, as well as positive 2 lies open. They are open. We cannot take these two quantities, positive 2 and negative. Otherwise, the rest is affordable in that case. Okay, cool. Moving towards another elegant question. Now, question number 7. What is the range of f of x? We are asked to find what is the range of f of x. F of x means modulus function. F of x is modulus function. Its graph is given by the v. Whether you put positive values or negative values, both result in positive. That is the graph of f of x. F of x modulus x. That is the graph of modulus x. That is the graph of modulus x. Its range is positive real numbers. Positive 0 towards positive. 0 towards positive, sorry, open interval. Semi-open interval, or semi-closed. 0 is included, infinity is not a number, it is a behavior, just keep along. Range of modulus function is always positive, always positive. 0 is affordable, f of 0 results in 0, it's good. That is the range, What about domain? All real numbers is the domain, and domain is all real numbers, right in that fashion or in that fashion, negative infinity to positive infinity. In case of domain, we have to avoid two things. Root never be 0, there is no concept of root, and denominator doesn't 0, and there is no denominator. It's okay, cool. Moving towards question number 7. F of x is a linear function, and we have given two conditions, f of 3 is equal to minus 3 and f of minus 3 is equal to 7. Then find the function in that case. F of x is a linear function. F of x is a linear function. Linear function means having power 1. So that is the general form of linear function. F of x is equal to ax plus b. And we are interested in the values of a and b, and we have given two additional conditions. They are f of 3 is equal to negative 3 and f of negative 3 is equal to 7. F of negative 3 is equal to 7. Then we are asked to find f of x. Here f of x is a linear function. I have written general form of linear function. If options are present, just put inside x is equal to minus 3. If result minus 3, that's your option. If put x is equal to minus 3, result is 7, it's your option. Or more orthodox or subjective type question, how to solve this? Let's see. F of x is equal to 3. Value of x is 3 and value of f of 3 is minus 3. Put here. f of 3, instead of x insert 3, sorry, a times 3 plus b, and value of f of 3 is minus 3. So we have 3a plus b, it's our equation number 1. We have generated this one, f of 3 is equal to minus 3, f of 3 is equal to minus 3. Then f of 3 is equal to 7, f of negative 3 is equal to 7, f of negative 3 is equal to 7. Put instead of x minus 3, f of minus 3 is equal to a times negative 3 plus b, and f of minus 3, it is equal to 7. We have minus 3a plus b, that's our equation number 2. Equation number 2. Solve 1 and 2. Solve 1 and 2 like simultaneous equations. We have 3a plus b is equal to minus 3, and minus 3a plus b is equal to 7. First add, you will get the value of b. B plus b, 2b. 2b minus 3 plus 7, it's 4. So b is equal to 2. So b is equal to 2. B is equal to, take same equation, now subtract. Take same equation, now subtract. I have minus 3a plus b is equal to minus 3. Angle is okay? Good. Negative 3 and 3a plus b, what I have written. Okay, let me manage some space from here. Oh, it's okay. It's okay. I can manage. So we have equation 3a plus b is equal to minus 3, then, and second is 3a minus 3a plus b is equal to 7. First, we have added to get rid of a. Now subtract to get rid of b. Cancelled out. 3a, 3, it will become 6a. Minus 3 minus 7, it will become minus 10. So a is equal to minus 10 over 6 or minus 5 over 3. Minus 5 over 3. So our required function is, let me check, by adding b, we cancelled out. Okay. Value of a is minus 5 over 3. Plug in here. F of x is equal to, a means minus 5 upon 3x, and b is 2. B is R2. One can verify. Put x is equal to 3. Whether to get minus 3 or not, how check. Put x is equal to 3 here. F of 3 minus 5 over 3 times 3 plus 2. 3 cancelled out. I have minus 5 plus 2. Minus 5 plus 2. That results in minus 3. That results in minus 3. Cool. It's cool. If I put negative 3 here, whether to check we are getting 7 or not, let's see. Our function is f of x minus 5 over 3x plus 2. Now plug in x is equal to minus 3. Minus 5 over 3. X is minus 3 plus 2. 3 cancelled out, minus plus. 5 plus 2 is 7. 5 plus 2 is 7. In case of MCQs, such option is present. Just put x is equal to 3 to verify. The result is minus 3. Put minus 3, result is 7. It's cool. It's your option. Just tick. Okay. Now we have given a proper rational function. Numerator is in quadratic as well as denominator is in quadratic, and asked to find its domain of the function. F of x is equal to x square plus 6x plus 5 over x square plus 7x plus 10. Okay. Solve denominators. Here are some removable singularity. Don't worry about this. Factorize this. Whatever remains in the denominator, solve for 0. It's our, exclude this one. It's your range. It's your domain. Factorize numerator as well as denominator. Common factors must be cancelled out. Then take the denominator equal to 0. Solve for x. Exclude these values. That comes from the solution of the denominator. It's our domain. Let's see and find out how. F of x. 1 5 of 1, there is 1, there is 5. 1 and 5, that's 6. X square, 1x plus 5x plus 5. Cool. 2 5 the 10, 5 and 2 7. X square, 2x plus 5x plus 10. Taking x common, taking 5 common. Taking x common, taking 5 common, and get along. X common, x plus 1 plus 5 common, we have x plus 1. Look at this. Both brackets are identical. We are good to go with middle term breakup. Here x common, x plus 2 plus 5 common, x plus 2. So one bracket in the numerator is x plus 1, other is x plus 5. What about this? One bracket is x plus 2, other is x plus 5. Cancelled out. What we have left with x plus 1 over x plus 2. X plus 1 over x plus 2. Now solve for domain. For domain, if there is a root, no negative sign, no negative result in the root. There is no concept of root. What about denominator? Denominator doesn't ceases to be 0. X plus 2 is equal to 0. X is equal to minus 2. X is equal to. So we have to get rid of x is equal to negative 2. Our domain is all real numbers. Our domain is all real numbers excluding minus 2, excluding minus 2, except minus 2, because at x is equal to minus 2, the function never gives us a result, it is undefined. So we cannot afford x is equal to negative 2 in the domain, we cannot afford x is equal to minus 2 in the domain. First we have given a rational function, we have factorized and cancelled out the common factor. X plus 5 is the common factor. X plus 5 is the common factor. Whatever we have left with x plus 2 is equal to 0. X result in x is equal to minus 2. We cannot afford x is equal to minus 2 in denominator. So I have written the range all real numbers excluding minus 2. All real numbers excluding minus 2. Okay. Moving towards final question. We have given some graphs and we are asked to find whether it is a graph of a function or not, whether it is only a relation or function, whether it is a relation or function. Very cool concept here. Vertical line test. Draw a vertical line test, vertical line upon the graph. Draw a vertical line upon the graph. If the vertical line cuts the graph only at a single point, it's a function, otherwise not. Let me draw the first one for you again. Okay. We have to draw a vertical line upon this graph. Okay. If it cuts exactly at one place, it's a function. By virtue of vertical line test, it's a function. It's a function because vertical line cuts the graph exactly at single point. Cool. It's our function. What about the two? It's some sort of sine or cosine snack. Just loop. Draw any line upon the graph. It cuts exactly at one place. Yes, it's a function. Vertical line must cut at single point. What about this? Modulus type of graph. Graph of modulus function, it's V. Take here, cuts one, or you can draw. So you have to draw single line, single vertical line upon the graph. It cuts at single place, it's function. It's a function. What about this? Mathematically, it is known as parabola. It's known as parabola. If we draw a vertical line upon this, it cuts at two places. It's not a function. By virtue of vertical line test, it is not a function. The rest three figures are function. It's my tiny effort, you guys, to give you good idea about what do you mean a function, domain, range, how to check it is function or not. If we have given the domain, we are in a position to find range. If we have given range, then we are in a position to find domain as well. It's all by itself. Next.